You click Post Goods Receipt in the warehouse, and instantly, a cascade of 6-digit financial ledger accounts updates in the background. This automated translation from physical inventory to financial data relies on a hidden configuration bridge known as OBYC. This diagram shows the specific transaction we are going to trace, a purchase order for 100 laptop batteries, priced at 500 rupees each, for a total value of 50,000 rupees. Tracking this exact 50,000 rupee value from the loading dock to the final vendor payment exposes the exact mechanics SAP uses to keep materials management and financial accounting perfectly synchronized. When the truck arrives and those laptop batteries are unloaded, the physical value of our warehouse inventory increases by 50,000 rupees. This animated diagram shows exactly how SAP records that increase. It posts a debit to the inventory account for a positive 50,000 rupees. In SAP Financial Accounting, debits are always represented by positive numbers. You might expect the system to credit the vendor immediately, but we haven't processed the official invoice yet. So SAP uses a temporary bridge called the GRIR, or Goods Receipt, Invoice Receipt, Clearing Account. To balance the ledger, the system posts an offsetting credit of negative 50,000 rupees to this GRIR account. Credits in SAP are always shown as negative values. The act of logging the physical delivery creates a perfectly balanced zero-sum transaction. We legally recognize the inventory on our books while logging a pending liability, all without touching a single invoice. This data grid represents the OBYC configuration table. It shows how SAP determines which specific 6-digit general ledger accounts to use for that transaction, completely automatically. The process starts with the movement type. When you receive goods against a purchase order, movement type 101, SAP calls up specific transaction keys. It uses BSX for inventory postings and WRX for the GRIR clearing account. Next, the system checks where this is happening and what is being moved. It pulls the valuation area, usually your plant code, and the valuation class, which is assigned directly to the laptop battery material master record. By cross-referencing the transaction key, the plant, and the valuation class, the OBYC table pinpoints the exact debit and credit ledger accounts requiring for disbursing. The warehouse worker only needs to know they received a pallet of batteries. The OBYC configuration handles the strict compliance and double entry balancing required by the finance department. Days later, the physical goods are safely on the shelves, and the vendor mails you the official invoice for 50,000 rupees. Before we enter this into the system, let's test your understanding. The GRIR account currently holds a negative 50,000 credit. Pause the video and calculate what the next debit and credit entry should be. This animated diagram shows the result of the invoice receipt. We post a positive 50,000 rupee debit to the GRIR account. This cancels out the previous credit, bringing that temporary balance down to zero. To balance that debit, a credit of negative 50,000 rupees is posted to the specific vendor account. We have officially cleared the temporary holding account and recognized a concrete, actionable debt owed to the supplier. The final step in the procure-to-pay cycle happens when the finance team schedules the actual cash payout to the supplier. This diagram shows payment execution. The vendor account receives a positive 50,000 debit, settling the debt to zero. A negative 50,000 credit hits your bank account. Ultimately, this 50,000 rupees flowed systematically through goods receipt, invoice receipt, and final payment, touching 4 distinct ledger accounts. By translating movement types into transaction keys and material data into valuation classes, OBYC eliminates manual data entry and builds the foundation of real-time integration between materials management and financial accounting.